Alright, working on practice problems from Unit 3, Chapter 6. So practice problem A asks us to find the start material for this product. So the most important thing here to do is to number our carbons. 1, 2, 3, 4, 5, 6, and 7. And then to realize that what O3 does is clip alkenes and turn them into carbonyls. So we look for the two carbonyls and say we need to form a pi bond or a double bond between carbon 1 and carbon 6. So we'll do that first. I'm going to say this is carbon 1, this is carbon 6. And we start going around the ring until we find what else is there. So carbon 1 was bonded to carbon 2, 3, 4, and 5. Carbon 6 was also bonded to carbon 7. You put that in here. And then carbon 1 also was bonded to a phenyl ring, so we need to add that in here too. And that's the best way to find this product. Okay, let's work on problem B. This is a hydrogenation. Oops. Dry material is an alkene, as it is with all the problems so far we've done. You have H2, palladium on carbon. Most important thing about H2, right? This is, remember, it's a cis addition. That means both you're going to add two hydrogens, they both have to be on the same side, and it's going to be racemic if we form stereocenters. So this is what the product should look like. You don't need to worry about the mechanism for this one. Right, and the other H, of course, came on the same side. We'd also make its enantiomer, so we say plus that. And the enantiomer, of course, since we formed one asymmetric center, the enantiomer is going to be the exact opposite. So in this one, the H is going to be coming up, and the methyl will be going back, but we still have the other H going up, the other H going back. The biggest point here, cis addition, and we get racemic mixture, which racemic means a 50-50 mixture of R and S enantiomers. Alright, let's look at number C. Now this one, same starting material as problem B, but to highlight a point about a different set of reagents, how can we get different products, a different regioselectivity. Number 1 and 2, of course, are important to remember. That means two distinct steps. So let's see. So the first step here is we got to draw boron having that empty p orbital being sp2 hybridized, and having that empty p orbital. First step, what's my electrophile? Is my nucleophile. The nucleophile is the pi bond up here. It's going to attack that empty p orbital, and at the same time, in one step, one of the H's on the boron is going to attack. And it's going to attack, if we number our carbons, 1 and 2, the less substituted carbon, because the boron has trouble getting to carbon 2. So again, the most important thing to remember here is that the boron has to go to the less substituted carbon, carbon 2. So it's less substituted. It's a cis addition. Both the boron and the hydrogen will end up being on the same side. So let's see what that looks like. So in this case, methyl will be up, H would be there, and the B, H2 will be on the bottom side, and there'll be an H. This here that was already on carbon 2. That finishes step 1. Step 2 just involves OH minus and H2O2. You weren't asked to know that. All you do in this case is replace the boron with an OH minus. So OH, H. But again, remember, carbon 1 and carbon 2 are sp2 hybridized. They're trigonoplanar. The boron also could have came from the top, so you'd get two products. So up here we'd say it's also racemic. If you form asymmetric centers, it's racemic. So in this case it is. So you also get the enantiomer. And the enantiomer looks like this. Where the H would now be here. The OH would be on the top. So the H and the OH are always on the same side. It's that cis addition. The methyl will be going down. And here you'd have the H. Alright, let's take a look at D. So for D, we have H2SO4, and then below we have solvents, water, and methanol. And it's saying it's in a 50-50 mixture. First thing you want to do, you see H2SO4, strong acid, it basically means, it does mean H+. H2SO4 means the same as H+. So as we've done before, the pi bond attacks the nucleophile, the nucleophile attacks the electrophile. And if we number our carbons 1 and 2, we see that the molecule has some symmetry. So 1 and 2 are really just the same. So we'll put a plus charge here, put the new H bond there. Now at this point we go back and remember we have these two mixtures of both water and methanol. So really we'll get two products, because water could attack or methanol could attack. The other thing to remember is carbocations. A carbocation is sp2 hybridized, and there'll be no preference for attacking the top or the bottom. The top or the bottom for either one. So you get two types of products plus their enantiomers. And here at this point you'd also get both enantiomers for both these as well. So when you have a carbocation, you get racemic mixtures, but no preference to cis or trans.